Hello everyone, today we're going to cover density and pressure. So what is density first? Well, density is, the definition is basically the mass divided by the volume of it. So what does it actually mean? Okay, so we have, let's say, two different examples. Let's say we have metal here and water, because we all know what density is, okay? So we know the mass is the number of atoms a body has, okay? And the volume of it would be, well, basically, yes, the volume, and is measured in meters cube. So let's say we have this 2D model representation of metal and water. As you can see, metal has a lot more density than water, which means that if we put our hands through metal, it's not just gonna, like, our hand is not gonna go through it. But water, we can actually just touch water and we can put our hand through it, and it's just gonna kind of absorb our hands. So what is this? Okay, why is this? Because we all just take this for granted. But what it is that metal has a higher number of mass, which is number of atoms, in the same volume, when water actually doesn't have nowhere near as much number of atoms, which is actually the mass, in the same volume. This is why they have different kind of densities, right? So this is kind of like a rough explanation of what density is, okay? And as you can see here, there's two different well, I'm not gonna call it pictures, but different drawings of what metal and water would look like if they were represented in a drawing. So now that we know the definition, right, density can be the unit, the SI unit, which is the is pascals, is PA, as you can see here, okay? But some people prefer to just say kilograms by a meter cube, which is fair enough. So I'm gonna be working with pascals, okay, which is the SI, which is the international system we use all around the world. So let's do a little example, right? Calculate the density of water, knowing that 1 liter is equal to 1 kilogram, okay? So water is the only fluid which 1 liter is gonna be equal to 1 kilogram, okay? Just in case you didn't know that. And another thing we should know here is that 1 liter is equal to 0.001 meters cube. I think some of you should know this already, but if you don't, well, here you have. So we know that we don't know the pressure, we don't know the density, right? So we're gonna keep this as interrogation. We do know the mass, do we? We do know the mass, which is 1 kilogram. And do we know the volume? Well, we do know the volume, do we? Because the volume is measured in meters cube, right? As we have here, because 1 kilogram is equal to 1 liter, let's say, then 1 kilogram would be the same as 0.001 meter cube, which this means that the volume is going to be 0.001 meters cube. So now that we have all of this, we write down the equation again, which is P is equal to M divided by V. So we have that the pressure, which is, we don't know it, yes, is equal to the mass, which is 1 divided by 0.001. And this, as you will see, is equal to 1, 2, 3. So it's 1,000 pascals, okay? So that's this is something you should know as well. That the density of water is 1,000 pascals, okay? And I think the air one, it's I'm not actually quite sure, but it's obviously lower than water for obvious reasons. So now that we know what density is, let's just cover pressure. So there's two kind of pressures, okay? There's the pressure we can apply into solids, and the pressures applied in fluids, okay? And they have different equations, so you should actually be able to differentiate when to use which, okay? So it depends on the title of it, okay? So depending on the exam, so in the exam says find the pressure on someone sitting on a chair, then that's a solid, okay? But if it's talking about water or any kind of fluid, then you use the other formula. So basically, we have for solids that the pressure, which is capital P, and don't mix them up, okay, capital P is equal to the force by the area per meter square. So this actually makes sense, okay, because do you ever feel like you are sitting on a chair and that's okay, as the man here is Bob, but then when you're trying to reach something and you stand on a chair on 1 feet trying to reach something on a high shelf, then you feel like the chair is going to break even though it's the same weight. Okay, which actually comes out of logic, and there's all physics, which means that if your area you're applying here, okay, Bob is, let's say, it's applying 0.5 meter square, okay, his ass, basically, when he's sitting down, the area is a lot greater than this man here, Bob, like Bob number 2, when he's standing up, because the area might be 0.01 meter square, because his feet are really small. So what this means is that because this man has more area, the pressure here is going to be less than the pressure here, because the area is a lot smaller, okay? So this is what it means. And then fluids, okay? Basically, the pressure we applied here has a little trick. And the trick is that sometimes, let's say here, Bob is, for some reason, it's a tiny little thing. When you're watering this, if you're swimming in the swimming pool, right? And let's say you go really low or really deep, you start feeling like a lot of pressure. This is because there's a lot of the height between the top of the water and you is greater than when you're not in the water, basically. So this is the trick, okay? I'll explain that in a second. But basically we have that pressure is equal to density of the fluid multiplied by the gravity, basically acceleration due to gravity, multiplied by height. But what height is this? Okay, the height is actually the height between Bob, let's say his head, okay? Well, doesn't normally we just apply it to the head, but we just take it for granted. Would be from the head to the top of the water, okay? It's not this height here, okay? It's not this one here. No, it's not, okay? Is the one from the top. That's the pressure. That's the height we use, okay? So be careful with this. So let's do 2 little examples here. Let's say we have, what is the pressure applied by a man whose weight is 80 kilograms on a chair he's sitting on, which is, let's say, 0.5 meter square. So we have that pressure is equal to the area force by area. So if the pressure force, so if his weight is 80 kilograms, okay, so well, we have F is equal to ma, because force is measured in newtons, okay, and we're given the mass, we're gonna have to transform this into newtons. How do we do this? Well, with F is equal to ma. So F is equal to mass, which is 80, multiplied by 9.8, which is acceleration due to gravity. Okay, so we're going to get a rough estimation of 800, okay? And again, I'm doing this without calculator, so I'm going to get a rough estimation. I'm just doing it by head, on my head. So we're going to get 790, more or less, divided by the area, which is 0.5. And what this means is that the pressure here applied is going to be 1,580. And then the unit is newtons meter square. Okay, so that is it. So fluids. Basically, we have like, what is the pressure felt by a fish underwater if it's just in the middle of a water tank, which height is 1 meter. So we have to draw it out to understand. Let's say we have a water tank here, okay, and this is the goldfish. No, jeez, that's an infinite. The fish is just in the middle, which means that if this is 1 meter, okay, the just middle part is gonna be 0.5 from the top, isn't it? So if we have the formula, which is P is equal to little p g h, we have that the pressure is equal to the density of water. But wait a minute, we did get the density of water here, which is 1,000 pascals. Okay, so we can use it here. Again, don't use this if it's the pressure of another fluid. Let's say, so I don't know, oil or any kind of fluid, because it might be different, and it will be different. So we have that as the pressure, as the density. Then we have 9.8, and then the height, which would be 0.5. Okay, and that be the result. Okay, and this all multiplies, and the units, it's a kilogram meter minus 1 s minus t, and that's the unit. Okay, so if there's any questions, just ask. I'm gonna upload this sheet and I'll into Dropbox, and I will put the link into the description so you can download it. And thanks for watching.